All right, so by popular demand, we're talking about Chapter 1, Number 32. This has to do with intensive or extensive properties of matter. So there's a reason I threw this in as a suggested problem. We'll talk about it here in a minute. But the first thing to keep in mind is if you look this up, because I don't remember if I talked about it exactly or not, but it was just a way to divide properties of matter. Um, Intensive means it doesn't matter how much there is of the substance. So regardless of how much there is, an intensive property doesn't change. If I take half the stuff away, the intensive property remains the same. Whereas extensive would change depending on how much material there is. So, as I go through these, hopefully it'll be a little more clear what that difference is as well. So, with volume, this is an extensive property, so it does depend on how much there is. All right. So, for example, let's take a deck of cards here. It has a certain volume, takes up a certain amount of space. It's made of matter, right? So it has mass, has some mass to it, it has volume, it takes up space. But if I remove about half the deck, it takes up about half the space. So also has about half the mass. So mass would be another extensive property. So they are both dependent on the amount of matter present. So that makes them extensive. All right. So temperature, on the other hand, and this is one of the reasons I threw this question in, was temperature versus heat. I wanted to kind of see if I get you to think about that a little bit early. All right. So temperature does not depend on the amount of stuff present. If I have a pot of water that's, we'll say, I don't know, 80 degrees Celsius, so it's hot. I pour half that water out, and we're ignoring, let's say it's perfectly sealed, it's not exchanging heat with the environment, all that heat, we'll talk about that. Then it will still continue to be 80 degrees. Now, I can change the temperature of something, but I don't technically change the temperature by adding or removing material that's already that temperature. So, this is intensive. All right. So it does not matter how much of the material I have. Humidity. So maybe you're familiar with the definition of humidity, maybe not. So it's how much water vapor is in the air, and it's measured by a percentage of the maximum that we can have. And so it doesn't matter if I'm in a large room and then, I don't know, a divider comes in and cuts it in half. If it was 50% humidity, the divider comes in, it's still 50% humidity. So once again, this does not depend on how much stuff or space is present. So it is an intensive property as well. It just doesn't, it's not that it can't change, it's just that it's not changed by having like more or less air present at a certain humidity. All right. So that brings us to heat. And again, this was, so B versus D. This is a subtle thing, and we'll go into this a lot more in a future chapter. But sometimes I like to kind of poke you ahead a little bit and see what comes out of it. So maybe it was smart to ask about this question. Temperature, that's how hot something is. It is that temperature because it carries a certain amount of heat. So this is actually a form of energy. All right. So heat gets transferred and temperature changes accordingly. So heat is a quantity of something, and it is proportional to the number of atoms. So if I have, a giant block of hot metal, and then I remove half of it, what remains is half of that metal, and it holds half of that heat energy. The other half went away. So this is an extensive property. So it does matter how much material I have. So an example of this would be like a heat battery, if you've ever heard of those. Typically, they're a large, very, very large insulated vessel full of sand. You think like, oh, heat battery's got to be this like cool thing, maybe it's lithium ion. No, it's just sand. And then you just make it really hot. And then you pipe water in or out of it or whatever. So you get it hot through extra electricity or whatever, just as a way to dump it off when you're not using it. And then you can hang on to that heat energy and use it to heat, say, like a neighborhood or a home or a large warehouse or something. And what you do is you just run water through and it comes out hot. Or maybe it even comes out as steam. That's how hot this sand will get. And so If we were to remove half of that hot sand, we would lose half of the heat. We would lose half of our stored energy in that battery. That's heat. And so it is dependent on the amount of stuff present. The atoms are holding on to the heat. If you remove half of the atoms, you're removing half of the heat. All right. So next is boiling point, and last is boiling point. And this is intensive. It just depends on what the material is, not how much of it there is. All right. So you boil a pot of water. Its boiling point, if it doesn't have much stuff dissolved in it, and you're at sea level, 100 degrees Celsius. Okay, so that's for a pot of water. So that's maybe a couple quarts. You want to boil 100 gallons of water? Again, just pure water, sea level, 100 degrees Celsius. That's the temperature. So it is intensive property. You have to put more heat in to get that water to heat up to the boiling point, but that temperature that it boils at is the same across the board. So this idea of temperature, heat, and boiling point, these are going to come up a lot more later. So volume is really the only one we've actually talked about so far. So I wanted you to kind of poke around with some other ideas. That was the main reason I chose this question. So hopefully that kind of helps make sense of what was going on here. And so this idea of intensive versus extensive is just, does it matter how much there is, or or does it matter how much there is or not? I have written backwards from my notes there. Sorry. So volume, it does matter. Temperature, it does not matter. Humidity, it does not matter either. All right. Heat does. It does matter how much stuff there is. And boiling point, it does not. Whether you're boiling a cup of water or 500 gallons, 100 degrees Celsius. All right. So that's how you look at number 32.